All right, so get this. We're diving into a research paper that's causing quite a stir. It's called LLaMA-Mesh, Unifying 3D Mesh Generation with Language Models.
Interesting title.
Yeah, and the concept is pretty mind-blowing, too. You know all those AI chatbots that are all the rage right now?
Yeah, seems like everyone's talking about them.
Well, imagine taking that tech, but instead of just spitting out text, it can actually create 3D models.
Wow. So you just talk to it and it designs something in 3D.
Exactly. That's what these researchers are working on.
Yeah.
And get this, it could have huge implications for everything from, like gaming and VR to even like everyday design tasks.
So like instead of using complicated software, you could just tell the AI what you want and it would create it for you.
Yeah, it's pretty wild. And that's what we're going to be exploring in this deep dive today.
It sounds fascinating.
It really is. So let's jump right in. The paper starts by talking about LLMs, or large language models.
Those are the brains behind those chatbots, right?
Exactly. But the thing is, LLMs are designed to process and generate text. So how do you even begin to explain a 3D shape to something that's used to dealing with words?
Yeah, that's a good question. I mean, how do you even translate something visual into a language that an LLM can understand?
Well, that was one of the big hurdles the researchers had to overcome. And their solution was pretty ingenious, actually. They used something called the OBJ file format.
OBJ files, those are for 3D models, right?
You got it. It's a text-based way to describe 3D models. So instead of trying to teach the LLM a completely new language, they cleverly leveraged something it was already familiar with.
That's pretty smart. So they found a way to basically sneak in the 3D information by disguising it as text.
Exactly. But here's the thing. 3D models can be incredibly complex. You're talking about tons of data points, all those vertices and faces that define the shape.
And wouldn't that be way too much information for an LLM to handle?
Absolutely. Even the most advanced LLMs have limits on how much data they can process at once. So the researchers had to find a way to simplify those complex 3D models into something the LLM could digest.
And how did they do that?
Through a process called quantization.
Quantization.
Yeah, you can think of it like compressing a file. You know how when you compress an image, you might lose a little bit of detail, but the overall picture is still recognizable?
Right.
It's kind of like that. They basically simplified the 3D data by reducing the number of data points used to describe the shape.
Makes sense. But how do they do that without losing the essential information about the object's shape?
Well, it's pretty complicated, but basically they divided the 3D space into a fixed number of bins and then assigned each point in the 3D model to the nearest bin.
Oh, I see. So instead of representing every single point with precise coordinates, they grouped them together into these bins.
Exactly. And that simplification made the data much more manageable for the LLM to handle.
Clever. So they found a way to make the 3D data bite-sized for the LLM without completely sacrificing accuracy?
Exactly. So they had this LLM that could now theoretically understand 3D models in this simplified format.
Okay, so they had the language part figured out, but how did they actually teach the AI to connect those 3D models with specific words and descriptions?
Well, they used a really powerful LLM called LLaMA 3.18b instruct, and they basically fine-tuned it for this specific task.
Fine-tuned? What does that mean?
You can think of it like showing the AI flashcards. On one side is the text prompt, say a red chair, and on the other side is the corresponding 3D model of a red chair in that OBJ format.
So through repetition, the AI starts to learn the relationship between words and shapes.
Exactly. And what's really amazing is that even before this fine-tuning process, the LLM was already able to generate some basic OBJ files on its own.
Wait, really? How is that even possible? I mean, hadn't it only been trained on text data up to that point?
Right. It's kind of mind-blowing. The researchers actually included some examples of this in the paper in Figure 6.
I'll have to check that out.
Yeah, it's worth a look. But it suggests that just by being exposed to massive amounts of data during its initial training, the LLM somehow developed this rudimentary understanding of how 3D models are structured.
It's like it picked up some spatial awareness just by osmosis. Pretty impressive.
It really is. But of course, the fine-tuning process took it to a whole new level.
So after they fine-tuned it, what were the results like? Could it actually generate complex and detailed 3D models based on text descriptions?
You bet. They were able to generate a wide range of objects, from simple shapes to more intricate designs, all from text prompts.
That's pretty amazing. So it could create like a chair or a table or even more complicated stuff.
Yeah, and it gets even cooler.
Yeah.
The model can actually generate multiple variations of the same object from a single prompt.
So if you ask for a chair, it might show you a modern chair, a vintage chair, maybe even like a futuristic chair.
Exactly. And that suggests that the LLM is not just mimicking what it's seen before, but actually understanding and applying concepts creatively.
That's really impressive. It seems to be grasping the underlying idea behind the prompt and expressing it in all sorts of different ways.
And that creative potential is one of the most exciting aspects of this research. It opens up so many possibilities for how we design and interact with the world around us.
Yeah, it's definitely pushing the boundaries of what AI can do. It's like we're witnessing the birth of a whole new era of design and creativity. But I'm curious, are there any limitations to this technology? I mean, it all sounds pretty amazing, but surely there must be some downsides, right?
Oh, absolutely. It's important to remember this is still early stage research. It's not perfect. There are definitely some kinks to work out.
Like what? Give us the dirt. What are some of the challenges they faced?
Well, for one thing, remember that quantization process we talked about?
Yeah, where they simplified the 3D data.
Right. Well, that simplification can actually lead to a slight loss of detail in the final 3D model. So you
Yeah.
get the overall shape, but some of the finer details might be missing.
Ah, I see. So it's a trade-off. Manageability for the LLM versus detail in the final output.
Exactly. It's probably great for generating initial concepts and overall shapes, but maybe not quite ready to create those super detailed photorealistic models.
Makes sense. So what else? Any other limitations?
Well, another one is the context length we talked about earlier. Even with quantization complex, 3D models still require a lot of data to describe. And for now, the researchers were limited to models with a maximum of 500 faces.
500 faces.
Yeah, which basically puts a cap on how intricate and large scale those designs can be.
So there are some practical constraints to consider, but even with those limitations, this technology has some pretty mind-blowing potential. What are some of the applications that have you most excited?
Oh man, where do I even begin? The possibilities are truly vast. Just imagine designing objects simply by talking to your AI. Need a new bookshelf. Just describe it and boom, you've got a 3D model ready to go. No more struggling with complicated design software.
That would be a game changer for anyone who's ever felt intimidated by traditional design tools.
For real. And think about the implications for fields like gaming and VR, where 3D assets are so crucial. This could seriously speed up the development process and create some incredible immersive experiences.
Totally. And you know what else? This could revolutionize education, too. Imagine AI tutors creating customized 3D models to help students visualize complex scientific concepts or historical structures.
It could make learning so much more engaging and intuitive. Like you said, the possibilities are endless.
Mm-hmm.
And it really makes you think about the nature of creativity itself and how we define it. Are we blurring the lines between human and machine creativity?
It's a fascinating question, isn't it? And I think it's one that we're going to be grappling with more and more as AI continues to evolve.
Absolutely. But let's not get ahead of ourselves. For now, let's take a deeper dive into some of the technical details of how LLaMA-Mesh actually works. We'll come back to those philosophical questions later.
Sounds good to me. Let's get into the nitty-gritty.
All right, so one thing that I found particularly intriguing was the use of a conversational dataset called UltraChat in training LLaMA-Mesh.
UltraChat. Why is that significant?
Well, it shows that the researchers weren't just focused on teaching the LLM to create 3D models. They also wanted to make sure it could interact and communicate in a more natural, human-like way.
Interesting. So by training it on conversational data, they were essentially helping it develop a voice and a better understanding of how humans actually communicate.
Exactly. It's not just about spitting out 3D models. It's about having a more fluid and collaborative relationship with humans. And that's key to developing AI that can truly be a partner in creativity and problem solving.
That's a great point. It's not about replacing human intelligence. It's about augmenting it, helping us achieve things we could never do on our own.
Right. And that's why I find this research so exciting. It's hinting at a future where design becomes more intuitive, where we can visualize and solve complex problems in new ways, and where the boundaries of creativity are constantly being pushed. But we also have to be mindful of the potential downsides of this technology and think about the ethical challenges it presents.
Absolutely. Power comes with responsibility. We can't just ignore the potential negative impacts. We need to be having these conversations now.
You're right. We need to be thinking critically about things like bias in the data and the potential impact on jobs.
Agreed. It's important to approach this technology with both excitement and caution. We need to ensure that we're using it in a way that benefits society as a whole.
Couldn't have said it better myself. But we'll dive into all of that in more detail in the next part of our deep dive.
I'm ready for it. Bring on the ethical dilemmas.
You got it. We'll be right back after a short break.
It's funny, when you really start thinking about this research, it makes you question what we even mean by creativity. Like, is it something that's uniquely human? Or can machines genuinely be creative too?
That's a question that's been debated for ages, especially with the rise of AI art and music generators. But LLaMA-Mesh adds like a whole new dimension to that discussion, literally. It's not just like rearranging existing designs, it's taking a text prompt and generating something entirely new in 3D space.
Yeah, and what I find fascinating is that Llama Mesh isn't just copying. It seems to be actually grasping the concept behind the text and then expressing it in this completely different form, a 3D model. And that's what we usually associate with human creativity, right? That spark of originality.
Yeah, that ability to take an abstract idea and then make it tangible. But if AI can do that, does it somehow diminish human creativity? Or is it more like AI is just expanding the definition of what creativity can be?
That's the million-dollar question, isn't it? And I don't think there's an easy answer. But what LaMesh does highlight is this close connection between language and spatial reasoning. We often think of those as separate skills, but this research suggests that they might be more intertwined than we realize.
It makes sense when you think about it. Like we use language to describe objects and spaces all the time. The round blue ball is under the square wooden table. We can picture that scene in our minds because we inherently connect language with spatial understanding.
Exactly. And Llama Mesh is essentially doing the same thing, but in reverse. It's taking words and then translating them into this spatial representation, a 3D model. And in doing so, it's kind of giving us a glimpse into how our own minds might be processing language and spatial information.
It's almost like we're using AI to unlock the secrets of our own cognition. We're holding up a mirror to ourselves, trying to understand how we think and create. Which leads to another big question. What does it even mean to be human in a world where AI is becoming increasingly capable?
It's a question that's both exciting and a little bit unsettling, right? We often define ourselves by our unique abilities, like our intelligence, our creativity, our emotional depth. But as AI systems become more advanced, those lines start to blur. If AI can design and write poetry and compose music, what does that mean for human exceptionalism?
It's a real challenge to our sense of self, isn't it? If we're not the only ones who can create, what makes us special? But maybe that's the wrong way to look at it. Maybe instead of fearing AI, we should see it as an opportunity to redefine what it means to be human.
I like that perspective. Maybe our uniqueness doesn't lie in specific skills, but in our capacity for growth and adaptation and self-awareness. Like we're constantly evolving, learning, pushing the boundaries of our understanding. And AI can be a part of that journey. It can be a tool that helps us reach new heights.
Instead of seeing it as a threat, we can embrace it as like a partner in creativity and innovation. And who knows, maybe by studying AI like LLaMA-Mesh, we might even learn something new about ourselves and the incredible potential of the human mind.
It's a fascinating possibility, but let's not get too ahead of ourselves. It's important to remember that AI is still in its infancy. Llama Mesh is an impressive achievement, but it's just one small step in a much larger journey. And as AI continues to evolve, who knows what new wonders and challenges await us?
Well, on that note, maybe we should take a moment to remind ourselves exactly how LLaMA-Mesh learns and adapts. One detail I found particularly intriguing in the research paper was the use of a conversational dataset called UltraChat. What's the significance of that?
Oh yeah, that's a really interesting point. It shows that the researchers weren't just focused on teaching the LLM to create 3D models. They also wanted to make sure that it could interact and communicate in a more natural, human-like way. By training it on conversational data, they were essentially helping it develop a voice and a better understanding of human communication patterns.
So it's not just about spitting out 3D models, it's about having a more fluid and collaborative relationship with humans. That's a crucial step towards developing AI that can truly be a partner in creativity and problem solving, rather than just a tool that follows instructions.
Exactly. And that's what I find so exciting about this research. It's pointing toward a future where AI isn't replacing human intelligence, but augmenting it, helping us achieve things we could never do on our own.
It's a future where design becomes more intuitive, where complex problems can be visualized and solved in new ways, and where the boundaries of creativity are constantly being pushed. But before we get too carried away with all the positive possibilities, it's also important to consider the potential downsides of this technology and the ethical challenges it might present. So we've been painting this pretty rosy picture of AI as like a creative partner. But as with any powerful technology, there's always, a flip side. What are some potential pitfalls or maybe unintended consequences we should be thinking about with LLaMA-Mesh?
Well, one thing to keep in mind is that AI doesn't exist in a vacuum. right? It's shaped by the data it's trained on and the intentions of the people who create and use it. So understanding the limitations and potential biases of the technology is crucial.
Makes sense. I mean, we've seen this with other AI applications where biases in the data lead to biased outputs. How might that play out with LLaMA-Mesh?
Well, just imagine if the 3D models used to train LLaMA-Mesh primarily come from a particular culture or time period. The AI might then struggle to generate designs that represent a diverse range of aesthetics or cultural perspectives. So we need to be mindful of those limitations and strive for diverse and inclusive data sets to ensure that the AI isn't perpetuating existing inequalities.
So it's not just about the tech itself, it's about being responsible in how we develop and train these AI systems. We need to make sure they reflect the, richness and diversity of the real world. And what about the impact on jobs? Like if AI can create 3D models faster and cheaper, what happens to the people who currently work in those fields?
It's a valid concern for sure, and it's a question we need to be asking not just about LLaMA-Mesh, but about AI in general. As these technologies become more sophisticated, there's definitely a risk of job displacement in certain sectors.
It's not an easy problem to solve, but I think open dialogue and proactive planning are key, right? Maybe we need to focus on retraining programs for those whose jobs might be affected or explore how humans and AI can collaborate rather than compete.
Absolutely. We need to be thinking about these challenges now and finding ways to mitigate the potential negative impacts while also harnessing the power of AI for good.
It all comes back to that idea of responsible development, using AI in a way that benefits society as a whole. Instead of viewing AI as a threat, maybe we should see it as an opportunity to elevate human creativity and problem solving. Like, what if LLaMA-Mesh could free up designers to focus on the more conceptual and artistic aspects of their work, while the AI handles the technical heavy lifting?
Now, that's a thought-provoking idea. It's about collaboration, not competition. Imagine a world where architects can use AI to quickly iterate on designs, exploring different possibilities and pushing the boundaries of what's possible, or where artists can partner with AI to create immersive and interactive experiences that blur the lines between the physical and digital worlds.
It's a vision of the future, where AI empowers us to be more creative and innovative, where we can focus on the big ideas, the human elements, and let AI help us bring those visions to life.
And as we wrap up this deep dive, I want to leave you with a question to ponder. If you could talk to an AI to design anything in 3D, what would it be? What problem would you solve? What dream would you make a reality?
That's a fantastic question. It reminds us that LLaMA-Mesh isn't just about, cool shapes and designs. It's about the potential to unlock human creativity and imagination in ways we haven't even begun to explore. This is just the beginning, and it's going to be an incredible journey. Thanks for joining us on this deep dive into the world of AI-powered 3D modeling. Until next time, keep exploring, keep learning, and keep asking those big questions.